All right, so here is the test that's not really a test, but you can use it as a test. I'd love it if you would try first and see how many you got right and test yourself. Here are the solutions to it. Can you write degrees and radians? So we need to multiply it by pi over 180, and if you reduce it down, that's 7 pi over 5. That would be a point. Can you write negative 2 pi over 9 in degrees? Well, you multiply that times 180 over pi and reduce it down, and you get negative 40. That would be a second point if you got negative 40. Number 3. When graphed in standard form, the terminal side of an angle measuring 11 pi over 4 is in which quadrant? Well, likely you're going to want to convert it. So if I convert that by multiplying it by 180 over 4, I get 495 degrees. If I subtract 360 to find the coterminal angle that goes with it, that's 135, and then 135 is in quadrant number 2 if you draw it. So the answer there is B. Again, a point if you can do that. Which of the angles are coterminal to negative 150? Check all the ones that apply. So negative 150 is the same as negative, well, let's try it first. So first of all, add 360 to it. So 360 and negative 155 together, that makes 225, right? No, it doesn't. It makes 210. Silly. So which one's the same as 210? So in radians, that is 7 pi over 6. So that one is coterminal. If I take that and if I subtract 2 pi, I get negative 5 pi over 6. And if I subtract 2 pi again with common denominators, I get, that's 12, right? 12 and 5, that's negative 17 pi over 6. So this one is also coterminal. So I got 2 coterminals. Any other one? If I take 7 pi over 6, and if I add 2 pi again, that is 12 and 7. That's 19. So that's not it. Negative 19 is not the same. Add 2 pi again. So that's 12 pi over 6. 19 and 12 is 31 pi over 6. So I got one more here. So those three, that was tricky. So those three are coterminal. They share the same terminal point if you graph them, the same terminal side, as negative 150. So that definitely was a challenge. If you got all three right, that'd be like 3 check marks there. All right, can you write something in degrees, minutes, and seconds? So take the decimal. So the first thing we're going to do is multiply it times 60 and see what answer I get. That's 35.7. Then take 0.7 and multiply it times 60 times 60, 3,600. So if you multiply it by 3,600, or no, multiply it by 60 again, I should say. That's going the other direction. So multiply it times 60 again, and you get 4.2, or 42. And so the answer is 61 minutes, or 61 degrees, and 35 minutes and 42 seconds. Just like that. How about the other direction? So this one's going to be dividing. So take 27 divided by 60. So if you go 27 divided by 60, you get 0.45. Take 15 and divide it by 3,600. That's where that came from. And that's 0.0042. And then if you put it all together, you get 230. And then 0.4542, if you like. And that would be your answer. All right, use the circle below to answer each question. So I want to find the arc length of L. So the formula for arc length, we use the letter S, is the radius times the angle, but it needs to be in radians. So the radius is 9.5. The angle is 105. So I need to change that to radians. That's pi over 180. Now, you'd put that in a calculator, And your answer would be 17.4. Number 8, what's the formula to find sector area? That's 1/2 pi. That's 1/2 r squared theta. Sorry. There it is. So it's 1/2. The radius is 9.5. Square it. And the angle, again, needs to be in radians. So it's pi over 180. So put that in your calculator. And you get 82.7. This one has to be feet squared because it's area. Number 9, I didn't teach you about linear or angular speed, so we'll go, boop, I'm not going to worry about it. So we'll pick it up on number 11. Find the CD to the nearest tenth of a meter. So CD is right here. That's x. This is SOHCAHTOA. So to understand it, circle the angle. X is the adjacent side. 19 is the hypotenuse. So which one of these uses adjacent and hypotenuse? So the cosine of 64 is equal to x over 19. To get x by itself, will you multiply by 19 and then use your calculator? Make sure your calculator is in degrees, and the correct answer is 17. Nope, what is it? And the correct answer is 8.3 meters. For number 12, find angle W. That's right there. Again, from angle W, this is the opposite side, and this is the hypotenuse. So opposite and hypotenuse use sine. So it's the sine, I'll just call it W, is equal to opposite, which is 3, over hypotenuse, which is 11. To get W by itself, you do the inverse. And you know you could use arc or the little -1. This is what you would put in the calculator. Make sure your calculator's in degrees. And the answer is 15.8. Number 13. A fireman spots a stranded woman in the window of a 200-foot tall office building. From the point where the fireman is standing, the angle of elevation to the stranded person is 42 degrees, 33 minutes, and to the top of the building is 58 degrees and 6 minutes. How far from the ground is the woman stranded? So, this is going to involve two triangles. You ready? So the first triangle, it has a height of, so this is 200 feet. This is where that person is, stranded. So the angle to the top of the building is 58. We're going to use tangent. So we know the distance that the fireman is. Oh, we know the angle. We don't know the distance he is from there. So the angle to the top is 58. So we don't know these two things here. So first of all, to find this, we'll use 58.1. So tangent 58.1, that takes us to the top of the building. 200 feet to the top, that's x. So that, to get x by itself, multiply and divide or switch positions. So this is what you'd put in the calculator. So x is 124.5. Now that I know that x is 124.5, now I can find y. This little angle in here is to the person is 42. And, oh, you know what I didn't do? I just put down 58.1, but I didn't show how to do that. So 6 minutes divided by 60. So 6 divided by 60 gives you that 0.1 that you need. That's where 58.1 comes from. So the second one is 42 degrees and 33. So 33 divided by 60, that's almost like 0.5, is it? 0.55? All right, so 0.55 or 0.6. So the second setup here is using that angle. So it's tangent again of 42.55 to change it 2 degrees. The opposite is y, and now we know the adjacent side is 124.5. To get y by itself, we're going to multiply this. So this is the first answer, which is how far away is the fireman. We needed that to get to this answer. So 124.55 times tangent 42.5, and that's 114.3. Number 14. You're given a point. So x is -7. The y value is -1. The radius is the square root of x squared plus y squared. So that's the square root of 50. 25 times 2. So that's 5 root 2. So the square root of 25 is 5 and root 2 left over. So those are the values we're going to use. So let me summarize them again. X is -7, y is -1, and that's the radius right there. So sine is y over the radius. So if I make that look right, that's negative root 2. So multiply top and bottom by root 2. So that's negative root 2. Root 2 times root 2 is 2 times 5 is 10. Cosine is -7 over the same denominator. Again, multiply by root 2. And that's the answer you get. Tangent is y over x. That's positive 1/7. And now we have the reciprocals. So the reciprocal here would be 7. The reciprocal here would be negative, but it's 5 root 2 over 7. And the reciprocal here would just be negative 5 root 2 over 1. I don't need the over 1. So there it is. Turn the page. Number 15, if cotangent theta equals that, 24 over 7, and cosine theta is less than 0, name the quadrant that it lies in. So if cosine is negative, the x-coordinate is negative. If cotangent's negative, then the y must be positive, so that when you go x divided by y, gives you that answer. So negative, positive, we're definitely in quadrant number 2. What's cosecant? So we're going to draw a right triangle in quadrant number 2. And we're going to label it. So cotangent, that's x. So x is negative 24. The y value is 7. You can use the Pythagorean theorem or the square root of x squared plus y squared. That radius is 25. It's a Pythagorean triplet. Cosecant, by definition, is the radius over the y in this case. So the radius over the y. So the answer is 25 over 7. Number 16. Give the reference angle of 8 pi over 5 in radians. So first of all, to find the reference angle, a good place to start is to subtract 180 or subtract 5. So if I do that, so 180 is the same as pi in radians. That would be 8 subtract 5. That's 3 pi over 5. Right? I get a different answer here. Let me just double check to see what's happening. So 3 over 5, pi over 2. So that's actually too big. So there's no answer matches. So I need actually 2 pi subtract 8 pi over 5 to find the reference angle. That's 360. Common denominators. So that would be 10 take away 8. That's 2 pi over 5. Man, that was a little tricky. So the answer to the reference angle in radians is B. Number 17. Do you know your unit circle? So the value of cosecant at 5 pi over 4, that's a 45-degree reference angle. We're in quadrant number 3. So we take the y-coordinate and do the reciprocal. So the y-coordinate there would be negative root 2 over 2. So the reciprocal would look like that, times root 2. And you get negative 2 root 2 over 2. The 2's cross out, so it's just negative root 2. So the answer is C. 18, the value of tangent at 7 pi over 6. When it's in radians, you might want to convert it. If you did convert it, it would be 210. Either way, the reference angle from the denominator is 30 degrees. I know we're in quadrant number 3, and I know that all students take calculus. So in quadrant number 3, tangent is a positive value, right? So I can cross those out. So of what's left, what's the answer there? So for 30 degrees, it's root 3 over 2 and 1/2. If I go y over x, that's 1 over root 3. This is what it would look like if you rationalize the denominator. Number 19, the value of cosine at negative 2 pi over 3. So to understand that, I know the denominator is 3. It's a 60-degree reference angle. That's 1/2 and root 3 over 2. So that means the answer is either positive 1/2 or negative 1/2. So these are wrong. And then I just need to know the quadrant we're in. So to think of the unit circle, negative 2 pi over 3 would end up right here if I was measuring clockwise. So in quadrant 3, the x-coordinate is negative. So the answer is D. Number 20. What's the value of secant at negative pi over 6? So again, the denominator gives me a 30-degree reference angle. That's root 3 over 2 and 1/2. Secant's the reciprocal of the x-coordinate, so that can't be right. It's the reciprocal, so it's either positive or negative. If I think of what quadrant it's in, negative pi over 6 is right here in quadrant number 4. In quadrant number 4, the x-coordinate is positive, so the answer is B, 2 root 3 over 3. 21. Which functions have a value of 1? So tangent at negative pi over 4 is in quadrant number 4. This would divide to negative 1. That's not true. The value of sine at pi over 2, that's at the top of the unit circle. The y value is 1, so that's true. The value of cosine at pi is the x-coordinate there. That's negative 1 and 0, so it doesn't apply. That's wrong. The value of secant at 3 pi over 2, well, that's an asymptote. So 3 pi over 2 is 0 and negative 1. The reciprocal of the x value is undefined. And then the last one, what's the value of cotangent at negative 3 pi over 4? So that's here in quadrant number 3. So the y divided by the x gives you a positive answer, and the answer is positive 1. So that's the right answer, and that's the right answer. There's only 2 right answers that give you the answer 1. All right, number 22. Can you solve a triangle? Let's see that. So to solve it, we find all the parts that are missing. This is a side angle side triangle. So to do that, we use the law of cosines for side angle side. So if I want to find that missing side, I'll call it x. It's a very long square root sign. It's 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 53. So that's what you would put in your calculator, and the answer you would get is 13.7. So I'll put that here and here. So already we know that answer. Now we need 13.7. So now we know this is 13.7. So now to find a missing angle, pick one of them. So I'm going to pick Q. So the formula is inverse cosine. You start with the side opposite of Q. So that's 17. subtract, and then pick another side, square it, subtract, pick another side, square it, and then the denominator is negative 2 times 12 times 13.7. So that's what you'd put in the calculator. And then you would get 82.5. And then once you know what two of the angles, all you have to go is 180, subtract 53, subtract 82.5. So 180, subtract 53, subtract 82.5, and you get the answer 44.5. And you did it. All right, turn the page. In 23. So in 23, in triangle ABC, let's draw that. Triangle ABC. Angle C is 73. A to B is 20. A to C is 29. And it says find angle B. So this is a side-side angle. That's ambiguous. It could be no answer, one answer, two answers. So in order to figure that out, we're going to set up the law of sine. So that's sine 73 over 20. And what I'm looking for, sine B over 29. So I set up that ratio with the opposite angle and its opposite side. To get B by itself, we're going to cross multiply. And then to get B by itself, you do the inverse sine to both sides. Oh, I forgot a 20, didn't I? So you got to still divide by 20. And then it's the inverse sine. So if you get the angle by itself, you get 29 times sine 73 over 20, and it's the inverse sine of that. That's what you put in the calculator. You'll get an error message. So there's no triangle possible with that. 24, we're going to draw a triangle ABC. Angle B is 82. A to C is 34. B to C is 14. And then we're going to find angle A. So what type of triangle is this? So it is, again, a side-side angle. So it could be ambiguous. So sine 82 over 34. Sine A over 14. See if I can do this. So A is going to be the inverse sine of 14 times sine 82 divided by 34. So put that in your calculator, and you get 24.1. There is no room for the obtuse angle, so when you subtract 180, 82 is too big to add to it. That's the only possible answer, so the answer is C. Number 25. Two cables with lengths of 40 and 35 are tied to the top of a pole. So this one's longer, so that's 40, and that's 35. And it says the stakes are 30 feet apart. So down here is 30 feet all the way across. So that's what I know so far. And it says find the height of the pole in terms of it. So this is what I want to find. In order for me to find the height of that, I need to find this angle. So I'll call that angle A. I need to find this angle, and then I can use it to find. So I know three sides. I can find that angle. So that angle is using the law of cosines. And so the side opposite is 35 minus 40 minus 30 divided by negative 2, and then 40 times 30. So there's that. That's the law of cosines. So the angle that's there is 57, if you use your calculator, 0.9. Then we want to solve for y. Now we know side, angle, side. So we know this is 57.9. So now we have side, angle, side to find y. Oh, no, sorry. We have a right triangle. Let me back up. So now we have a right triangle, and I can use SOHCAHTOA. So that is opposite and hypotenuse. So now I can write down the sine of 57.9 is equal to opposite, which is y, over hypotenuse, which is 40. SOHCAHTOA. To get y by itself, multiply by 40. Use your calculator, and you would get the answer 33.9. So there's the answer. 26, Philadelphia, that's in Pennsylvania, is 450 miles east. Here's Philadelphia. Here's Columbus. That's 450 miles east. The bearing from Columbus to Richmond is south, 60 degrees east. And the bearing from Philadelphia is south, south 34 degrees west. So, and then the question is, find the distance from Columbus to Richmond. So find this distance. So these are complementary. So this must be 30. And they add up to 90. So this is 56. Right? Just looking at. So now I know side, angle, side to be able to find this. So if I know angle, side, angle, that's the law of sines. So I can find this angle here. So I can go 180, subtract 30, subtract 56. So that angle in there is 94 when you do that. So I know this angle. So now we start with sine 94 over 415. I'm looking here, the angle's 56 I need to use. And then to get x by itself, 415 times the sine of 56 divided by the sine of 94. And then use your calculator, and you get 344.9 miles. So that rounds to that, and you get your answer. Number 27. Find the area of this triangle. So how do you find the area of a triangle in this? So step number one is I don't have enough information. I need to know a side. So I'm going to find that side there. So if I go find this angle up here, that's 180, subtract 40, subtract 51. I think that's 89. That's up here. Now I can go sine 40 over 11 and sine 89 over x. Cross multiply. So multiply and divide. You get the answer 73.1. No, you get the answer 17.1. So now that you know that's 17.1, now the formula, the trig formula is side angle side, is 1/2 17.1 times 11 times the sine of the angle in between them. So 1/2 times 17.1 times 11 times sine 51. Put that together, and you get 73.1. That's where that came from. So the answer is A. Number 28. Triangular parking lot. I can draw that. Has sides of 90 and 54 and 128. Use Heron's formula. So for step number one is 90 plus 54 plus 128. Add them all up and divide by 2. So S then would be 136. Then the formula is 136, 136, take away 90, 136, take away 128, 136, take away what am I left with? 154. So 136, then 136 take away each side, and then you get the answer, 2025.8. So the answer was C. All right, some graphing. Cosine has an amplitude. It's 2. The period is 2 pi times the reciprocal. So if you put that together, that's 3 pi over 2. Cosine starts at the top of the wave. At 3 pi over 2 would be the top of the wave. Exactly in the middle would be the bottom of the wave. And then that's the pattern that you're going to follow as you go across. So 1, 2, 3, the bottom. 1, 2, 3, the bottom. 1, 2, 3, the top. 1, 2, 3, the bottom. So there's that. Fill in the middle points as you go across. There. Didn't do this middle point. It's there. And it's done. For number 30, cosecant has no amplitude. The period is 2 pi divided by 2. So it's just 1 pi. 1/2 gives me the vertex. Cosecant starts with an asymptote. At pi will end, and then in the middle will be a third one. Find 1/2, it goes up. Find -1/2, and it goes down. And that's the pattern. You don't have to fill into the ends of the graph. Number 31, cotangent has no amplitude. The period would be 2 pi times 2, which is 4 pi. Cotangent starts with an asymptote. We can't find 4 pi for another asymptote, so halfway there is 2 pi, and that would be a point of inflection. Negative cotangent goes up to the right and down to the left. So the direction here would be, in between, I would go to -3 because of the reflection, and then it continues that way. And same thing over here. I would go to +3. And there you have it. Number 32. The amplitude there, sine does have an amplitude. The period would be 2 pi times 3 over 8. That would be 3 over 4. Sine starts in the middle, 3 over 4, and then in the middle, so that's where it starts with. It goes up to 4, and then it goes down to -4. And there's the pattern back and forth. So 1, 2, 3. The middle, it goes up to 4, down to -4. 1, 2, 3. And the middle, it goes down, another middle, and then it goes down, and then up. 1, 2, 3. That's plenty now. And you have your weight. For number 33, this has shifts. A is 1.5, B is 1, H is positive pi over 2, and K is 1. Then we're going to take those values, come to the right. Secant has no amplitude. The period is 2 pi divided by 1. That's just 2 pi. The phase shift is pi over 2. And the vertical shift is 1, so everything's been shifted up 1. So I'm going to first start and draw the midline at 1. Then I'm going to go to the phase shift at pi over 2. And then, oops. Just do something quick here. All right, so at pi over 2, secant starts with an upper vertex at 1.5. So from the midline, go up 1.5. We would count 8 to the right, which is just a little bit off my graph. So I'll just cheat a little and put it there. Exactly in the middle will be 4 to the right. 1, 2, 3, 4. That's going to be the lower vertex. That'd be 1.5 down. And then in the middle, counting 2 to the right, would be asymptotes. Right? Oh, here. Then the upper ones fold up, the lower ones fold down, and so on. All right, number 34. Can you graph tangent? So A is 1, B is 4/3, H is negative pi over 2, and K is negative 2. Just going across. There's no amplitude for tangent. Period is 1 pi, and then I do the reciprocal. So I get 3 pi over 4. Phase shift is negative pi. The vertical shift is negative 2. So then I'm going to go to negative 2. And draw my midline. Tangent starts at the point of inflection. So at the phase shift, right on the midline, I'm going to start there. That's where my graph starts. The period is 3 to the right. 1, 2, 3. Also a point of inflection. In between is an asymptote, and we're going to get our pattern. So let's go 1, 2, 3. 1, 2, 3. 1, 2, 3. That's plenty. In the middle are asymptotes. And then what direction? The A value is 1. So from the midline, I go up 1. That goes up to the right, and then down 1. So from the midline, up 1, and then down 1. Up 1, and then down 1. And then continue that pattern. Up 1, down 1. Up 1, down 1. And you have it. All right, last part. Turn the page. Some inverse trigonometry. Do you know your unit circle? So this is the x-coordinate. Which one of these angles is the x-coordinate negative 1/2 in the correct domain restriction? So the only left are here. So it's a 60-degree reference angle, so it must be C. 36. So it's y over x. So that's going to be y over x. That's going to give me that answer. That's a 30-degree reference angle. So it's pi over 6. Number 37. These undo each other, and they answer, oh, but we need to change the angle to be the correct restriction. So 11 pi over 6. We're going to change that angle to negative 1 pi over 6. They're the same. So that's the A value there, negative 1 pi over 6. At number 38, we have the value of tangent at 0. So for this one, the value of tangent at 0, y over x is 0. The value of cosine at 0. So this is where we are on the unit circle. What's the x coordinate there? And so the answer, oh, let's back up. Sorry, it's 0. So now we're here. So this is where we started with y over x. That's what gives us 0. Then up here, we have the point 0, 1. So where is the x coordinate 0? At what angle? And so we get the answer pi over 2. At number 39, the value of cosine at 3 pi over 4. It's a 45-degree reference angle. So it's negative root 2 over 2. And then this angle is negative 45 degrees, or negative pi over 4. Number 40, inverse sine negative 1. So when the y-coordinate is negative 1, we're at the bottom of the unit circle. So that angle down there, in fact, I don't even need to know the angle. I can just use that point and go y over x. So the y value is negative 1. Using this point, what's tangent? Y over x. It's undefined, so it's not possible. Then the last part, 41 and 42. So question number 41, inverse sine of root 3 over 2. What angle is that? I don't need to know the angle. In fact, if I just, oh yeah, I do it here. What angle is that? That's the y-coordinate. The x-coordinate is 1/2, so this is a 60-degree reference angle. So that is pi over 3. What's the value of cosine there? What's the x-coordinate there? And the answer is 1/2. So I actually didn't need to. I just needed to know the point, and then cosine goes with the x-coordinate. Last one, not the unit circle. So the x-coordinate is negative root 7. The radius is 5. I need to figure out the y value. So if I drew a triangle with the Pythagorean theorem, I would end up with negative root 7 squared plus y squared equals 5 squared. And then I would solve for y. So that's 7. That's 25. Subtract 7. 25 take away 7. That's 18. So the square root of 18, that's 9 times 2. So that's what I'm looking for. Sine is 3 root 2 over 5. And there you go, right? Some were easy, some not easy. But you know what? You got to the end. I'm super proud of you. Mr. G Math over and out. But till next time.